it's your time. So if you want to start, you can.
Oh, but it was only 30 seconds. Very bad. Okay. Okay, don't worry. Well, this is an activity, a workshop related to eclipses, and is a workshop organized by NASE, Network for Astronomy School Education. And it will be presented by several members of NASE from different countries. In concrete, this morning will be Mahdi from Iran, Jiwaji from Tanzania, and Rosa from Spain. And this afternoon, we have another session that we speak Spanish in the other session, and will be with different speakers. Then I would like to introduce some ideas about astronomy, and after we talk about eclipses. The first idea that I would like to introduce is that astronomy really is a very special science, because have several aspects that they are different than other science. Normally, astronomy have an intense appeal since the beginning of time. The humanity is very interested, very motivated about different aspects, in some cases related to magical aspects of astronomy, of the sky, of the heaven. In other cases, astronomy was useful in order to collect their food. And then it is a mixture of different things that in all the cases very interesting for them. Also have one special ability in science that's not very common, that to foresee the future. Of course, this introduced some problems with astrology, but well, in any case, was special for this kind of science. Also, we have very simple observation that is possible to observe from the school. It's not a problem for us to organize activities with the students. And in some cases, we have very, very spectacular phenomena, free phenomena. So for instance, the eclipses that will be in a couple of days. In general, there are beautiful, very beautiful images of astronomy. This facilitates the diffusion of our science to the people. And I would like that you remember that we have a lot of amateurs. This is not common in science. There are not amateurs in mathematics or chemistry or biology. Then this means that astronomy have a special appeal. And also, I have a special characteristic of science that we can repeat in the lab, all the experiments that we want, but not in astronomy. Then it's a different science that I think it is special to fall in love the people with this special situation. In any case, all the schools have an astronomy lab because it's only the place that the children play football, for instance, and then they have a sky above this area, and always there are some days that it is possible to observe during the day and during the night. And then our suggestion is that the teachers have to use this facility, and this was the origin of NASE. NASE is a working group of the Commission C1, Education and Development of International Astronomical Union. And we organize mainly courses for secondary school teachers. In some cases, we have also primary school teachers, and in some cases also university staff. But the courses are mainly very, very practical. And we have one characteristic that I think it is the much more important of NASE, that the creation of local working groups, that they repeat the activities after 1 year or 2 years at the beginning. And after they continue working, and they help us to teach in different countries, some neighbors countries or other countries. We believe that it is absolutely important to teach the courses in the language of the country. In this moment, we have 14 languages. I have here Jiwaji, from Tanzania. He is the chair of a team of people that translate to Swahili the materials. And also we have Mahdi. Mahdi is the person that in this moment coordinate the practical finished edition of the book with all the contents in Persian language. Then, this is very important for us because the people cannot use always English. NASE have also a quality certificate that it was for external evaluation and ISO quality management system. And this is important in order to control the quality of our activities. This is the summary of NASE statistics. In this moment, November 2020, we have been finished 201 international courses. We participate in 60 other courses in cooperation with other institutions, and we are present in 50 countries in the world. We have 60 local working groups. There are more than countries because it depends on the country. In a big country, we have more than one. And we was working, we introduced to astronomy more than 7,500 teachers. And this could be involved, maybe, we don't know exactly because this is practically impossible to calculate, but about 7 million students if we consider an average that a teacher has 200 students per year. This is the map of our activities. We begin at first in America because with 2 languages, we have practically all the countries, and then it was easy for us. And in this moment, we are beginning to translate, and and we are organizing courses practically in all the world. This is the countries that we have present activities. And in order to practically finish my speech, I would like to repeat that astronomy is important in the life of the people, and especially in the school, because the society in general encourage the interest in science, promote teaching innovations, and stimulate scientific vocations. You could see how do we do it. Of course, we organize courses, but what is the thing that you remember best? I give you several seconds. Do you remember the first kiss? Not your mother kiss, no. The first kiss, you understand me if you want, okay? This was very special for you, no? And you remember all your life. Why? Because it was a special feeling for you, and a special emotion, and a special excitation, and a special new thing that you remember all your life. Then we want to create emotions. What we do, of course, we don't kiss all the participants, no. We offer them different things. We offer an observation, direct observations, models, activities, very practical things. We seek to excite, we seek to surprise in order to promote values and attitudes such as humility, because in science, a lot of times you are wrong. For instance, Pluto now is not a planet, it's only a minor planet. There are a lot of these things. Also, prudence, it is necessary to check, to verify, to control very well what you are saying, what you are doing. Rigor is not possible to be superficial, and the constancy. Constancy is absolutely important in science and in the life in general. Don't give up, never. And we seek to stimulate reflection, to think, to understand. And of course, it is very important, don't forget the impact For instance, the light pollution, the climate change, all of this is very important for all of us. In general, we seek to leave a positive mark on science, that the people enjoy, that this special feeling with science and with the participants. The people normally enjoy to go to the cinema, to the theater. Why? Because it was one time that was absolutely wonderful experience for him or for her. Then we want that they have the same feeling for science. And of course, there are some examples. Then, for instance, the eclipses that will be in December 14th, and then other topics also are very exciting for people. People is motivating to know more about exoplanets, black holes, habitability, pulsars, and also another emotion that I think it is very, very important. When you don't understand something and gosh, in one moment you understand. This feeling, this emotion is wonderful. And then I think it is normally something that you want to repeat. If you catch this feeling, you want to repeat again. And I would like to finish with one sentence of one of the students that I participated in one event that I organized, that they say to me, a group of students, they say to me that we have discovered that we like to discover. I think it's a wonderful sentence, a wonderful for a scientist person and wonderful for all of us. Then I think that astronomy helped to discover science for the general audience. Then the next speaker will be Mahdi about solar eclipses. Are you ready?
Yes, I'm ready. I want to talk about the gravitational lenses. Is that okay? Can you hear me?
Yes, yes. And
Yes.
you have here your presentation ready?
Yes. Should I share it or you can show to the participant?
Well, the idea is that we want to introduce the solar eclipses, and it was one eclipse that was very, very special in 1919, and these eclipses was test the Einstein prediction about the curvature of space produced by the presence of the sun. And then we want to introduce some practical activities relative to this topic. Okay, pass the next one, Mahdi.
Yes.
Okay.
Thank you so much, Rosa. Hello, everyone. I want to talk about the gravitational lenses and show some experiment to how we can simulate the position. It all started with a calculation by Albert Einstein that showed something about the stars. When there are two stars in front of each other, you can see the light of the background stars. It curves with the foreground stars, and you can see the position by that. And it calls gravitational lenses, and it magnifies the background star light. In the next slide, you can see by the simple experiment with clothes how the gravity works. When there is a mass and massive object in space, it always deformates the spacecraft like that, as you can see. And there is a reason about the light and the gravity, that we know that light always try to find the shortest path in a space. And when there is gravity, it is like a curve. In the next slide, we can see, for example, in when we are on Earth, in the globe, you can see that the light move and pass is like a curve, that you can see that. And with some simple experiment, we are going to see how it works. Can we go to the next slide, please? Okay. The position is very simple. We want to know that the observator always can see the deflector in front, but the position of the background star, galaxy, or quasar is important. And it deflects with two images above and bottom, that you can see two images of the background star. In the next slide, we can see how it works when the object has extended mass, or it will be symmetrical, and we can see a ring or circle around the object, and it's called Einstein ring. And there is some easy experiment that we can show it and simulate this position with simple objects. Okay. In the next slide, you know, it is easy because we can use simple objects like the glasses and use them to show the deformation of the space with an graph paper, and look through that to see the deformation at first. You can use a glass of white wine or water or something like that to show that, but we can see the more experiment about that and see what going on in gravitational lenses exactly. In the next slide, there is a very simple and beautiful experiment about that. You can use a glass of wine, or what we have here, a glass of fruit juice, like cherry juice or something like that, that you can use, and a light that you need to simulate the gravitational lenses. I can show you that, but for the best way we can use the video after I use that. It is very simple and easy. What we want to do is that to show the mass, and when the light pass through the gravitational lens and change the position, you can see the different images of the gravitational lens. Can we see, Rosa, the video I want to show and explain more about that? Thank you.
You see the video now?
There is no video, no?
No video, sorry. One moment.
And remember, the shape of the glass is very important. It has to be circle and like a curve, and use the light and change the position. That's what we want to see in the video to show this better.
Yeah, but I don't know how to show the video. I lost one.
You want me to show it?
Well,
Yes, you can change the speaker if you want. In a sense, the sharing the screen, sorry. You can change who share the screen if you want.
If you want, I can share it. Can I?
Yes, Rosa. Abandon the sharing the screen and Rosa? You are, yes, you are mute.
Can I see my video?
Okay. Rosa, you are mute.
You can see the video?
Yes.
Okay. Let's see. It's a simple image about it, and we use the light. Now, when we change the position, you can see a curve and the lights, which is like some curve around and make a circle. But when we change the direction, you can see the difference. Sometimes you only see 2 points, Can you see that? We call
Yes.
it, yes.
Yes, we can.
So in the different way, you can use different glasses like that. The shape is different and it changed the gravity, but the light is also different, but it's not so different. And you can see points of the light in different way. In some way like that, you can see the fragment of arc, just a fragment. And when you change the position, you only see 2 or 3 points. It depends on the mass or the position of the star. Another glass is simple like the other one.
Rosa, you are not sharing your screen, Rosa.
Yeah, I know. I have problems, sorry, because
I think this video is done. We can continue, Rosa, if you want.
now,
Yeah. Yes. No.
sorry. I make one mistake, I know. Sorry. Well, the next one is screen. I think it's this one, okay? You can see here. Yes,
Yeah. Okay.
sorry.
Now we have the screen of Rosa. Is that okay? Everyone can see that?
There are different phenomena, okay?
Okay. Oh, yes. And what we were seeing in the video is about the different position and different shape of the light in gravitational lenses. And when we change the position, we could see the different light in the gravitational lenses. For example, we can see the fragment of arc when it passes from the low angle, and when we change the position, we can see sometimes amorphous figure. And the Einstein cross was the most important and symmetrical position, and also Einstein ring. So thank you, Rosa, for showing that. So another experiment that we can use that I suggest always to use a bottom of the glass like that we have here to deformate and reflect the space and the light with that. This is the base of the glass like that. You can use anytime you want. You have to cut it and use that. And it's important to be a deflector and deformation from the center, not from the edge of the base of the glass. Okay. You can see also a graph to see the deformation of the space as you see in the last slide. And the most important thing is that you can look through the glass and see an object like that. And it's simple that you can see all of the deformation and the gravitational lenses work in that we was seeing in the last video. Rosa, can we see the next video, or
Yeah,
I can show it too if you can.
just a video.
You want me to show it again? Oh, thank you. So it is simple. You only need the base of the glass you cut before, and when you change the position and the direction, you can see at first the Einstein cross, again when you move it like that, you can see 2 points. And now it's gonna be more symmetrical, and you can see the Einstein ring. It's also, yes, like that. So when you change the position and going forward and back, you can see the difference. And it's only just to show how gravitational lenses works. And it's easy that you can only use something simple like that and see how it works. And remember, there are always other ways to do this, but these are simple ways. In the slide, we can see the pictures, Rosa, and I think, yes, thank you.
You can see the PowerPoint now? Yes?
Yes, we can
Thank
see
you.
that. And I want to show also in the camera, so simple that you can use these two objects, and by changing the position, you can see different images, like the arc fragment, just a fragment of arc, Einstein cross, and Einstein ring. When you change the position, and it's all symmetrical. And I think I'm done. The base presentation is over. But remember that what we can use with gravitational lenses, and that's what the moon do in the solar eclipses, for example. And that's the different project that we can use when the eclipse occurs. Thank you, everyone, for your attention.
Thank you, Mahdi. Thank you very much. And the next speaker is Jiwaji from Tanzania. Thank you. Jiwaji.
Thank you very much, Rosa. We would like to understand these other phenomena which are more common in our own environments. The phases of the moon, for example, we say the sky is our laboratory. So we look at the sky, we try to understand how the universe works. So one of the easiest things to do is to look at the moon phases. So how do the moon phases happen? See? So it is all a matter of position of the moon around the sun. So you can simulate the phases of the moon, and we'll see another model later on how to. This is how you can arrange a few people around a light source. What we want to do here is to show you how we can, because you see, the problem with astronomy is that we have a lab, the whole sky is the lab, but we cannot go into the lab. We have to bring the lab to us. How do we bring the lab to us? We do that by using models. Now, modeling is about transforming from reality into something that is manageable. Manageable means it has to be something practical. For example, if you want to model a moon, you want a moon to be a size which you can handle the sun, the earth, etc. So here we have a table where we show the proportionate sizes when you take the real sizes of the earth, the moon, the distance from earth to moon, the distance to the sun, and the size of the sun. We have these distances, and if we make one of them a unit, for example, in this table we have the moon is 1 unit, 1 centimeter. It is 1 centimeter is like a marble which you can handle. Now, according to that, how big would the earth be, for example? So you divide the moon diameter, the earth diameter by the moon diameter, and you get approximately 4. We are talking of just modeling, so, and things that we can make. So on the bottom, you can see here that there is a model which is made from using wood and some balls of something that can be a marble size moon and a small ball, which is the earth. So you can have, and the distance between the earth and the moon would come to about 1 meter, 120 centimeters. So if you, Rosa, if you can show on your screen, you can see the model which has been made here. So it can be made very easily. It's just a rule, a meter rule, approximately a little bit more than a meter rule, and you look for the balls of the respective sizes. Now, we want to use this to simulate. Using the model, we want to use this to simulate the eclipses and the moon phases. So in the next slide, we are showing how you can do that. If you take the model and you point it, the moon towards the moon that you see, this type of activity you will be able to do when it is daytime. Sometimes during the daytime, if the sky is clear, you can see the moon. So if you see the moon, and now you point that model with the moon pointing towards the sun, towards the moon, then the sun will be shining in the same way as it is shining on the earth. So this video is showing you how you can now align your model to be pointing towards the moon. So it is something that you would do it during the daytime, but then later we'll say how you can imagine it during nighttime also. Let's see the video.
All right. This is the video.
Yeah.
Okay. So in the sky, we have the moon, and then the model is being pointed towards the moon. So now when you're pointing towards the moon, the sun is shining on one side, which we see as the bright side, and on the model itself of the moon, you'll see the same bright part, which is shining from the sun that is on that side. So you'll see the phase even. You can see the phase even of the moon. So normally it will be a gibbous phase, because that is the time when the moon is high enough. Okay, so now if we go to the next simulation, let's look at lunar eclipses. The next slide, please. Okay, so lunar eclipses occur when the moon is full, but also the moon has to be full, and the sun, the earth and the moon have to be exactly in line. So the moon has to be on the other side from the sun, so that the shadow of the sun will fall on the moon. The shadow of earth will fall on the moon. So here also we can use the model, and we can show the next slide shows the use of the model. We have light on one side, and the shadow of the earth will fall on the model of the moon. So here the girl is pointing the earth towards the sun. So this is during daytime. So you can show that the shadow of the earth falls on the moon. Now there's a video which you can see where you can see the shadow completely covering the moon. Can we see the video, please, Rosa?
Sorry.
Okay, so in this video, you can see that when the shadow is not falling on the moon is full. It's fully seen. Now the shadow of the earth is now falling fully on the moon, because the earth is bigger, so it can cover up the whole moon. So we can have a total lunar eclipse. And if it's outside on the edge of the shadow, it would be a partial lunar eclipse. So you can see how you can align the model to be pointing, the earth to be pointing towards the sun, and the moon is on the other side. And you can see here now, the moon will go into a shadow. You can see that. So this is how you can easily show a lunar eclipse happening, including partial eclipse. You can also show easily. Okay, if you go on now to the next is the solar eclipses. Next slide, please. So for solar eclipses, it's again the arrangement of the moon, but the moon is now on the side of the sun. If the moon is on the side of the sun, we normally say it's a new moon. But if it's a new moon and exact alignment, exact line between the sun, the moon, and the earth, we get a solar eclipse. So we can also show this. If we use our model for earth and moon, we can show that the shadow of the moon will fall on the earth. So you can see on the next Next slide, you can see that alignment, how that is aligned. Can you move the slide, please, Rosa?
Yeah. 1 moment. Okay. This
Okay,
one?
so there we have the light falling from the sun, which is the torch, which is shining on the moon first, and then the shadow of the moon is, falling on the earth. Now that shadow is small, and we'll see. And on the next slide, you can see the picture first. Can you go to the next slide, please?
Yeah.
Yeah. So
Nice.
on a real model, yeah, next slide, yes. So on a real model, you can even see the small shadow of the moon. This is quite remarkable. This is something that we see from the International Space Station or something like that, from a satellite. But here we are able to show this directly in your hand, you know. And there's a video for this also, and we can show the video here, how it works in practical. Can we see the video, please, Rosa?
1 moment. You see now? Okay.
Yeah.
This is the video.
You can see when the moon is exactly pointing towards the sun, the small shadow of the moon is falling on the earth, and you can see even the umbra and the penumbra there. Did you see that on the outer edges it was slightly fainter than the central part? So that is the central part is the umbra, where it will be a total eclipse, and where the penumbra, it will be a partial eclipse. So this is something quite impressive, you know, quite a very impressive demonstration. You can see that. So this is quite easy to show. So, and then, of course, here you can also simulate the shadow passing from one end of the earth to the other. While the moon is rotating, the earth, the shadow will cross the earth in the opposite direction. So you can simulate that also. You can see the edges are fainter. So there's the penumbra where people will be seeing the partial eclipse, and in the darker part, people will be seeing the total eclipse. Okay. Thank you very much. So the next slide. So now there are many types of eclipses. Next slide.
Yeah. This.
So you can see here, there are several types of eclipses. There is the total eclipse on the top left. There is the total eclipse just happening on the top right. On the bottom left, the total eclipse is almost coming. So this is called a diamond effect. And then following that, on the center bottom is the annular eclipse, and on the right is the partial eclipse. I've been fortunate to see 2 solar eclipses, total eclipses, and 1 annular eclipse in Tanzania in 2016, and so many partial eclipses. I follow eclipses very much. Next slide, just to show how remarkable the effect is. You can see here, it's an amazing effect of the world becoming dark as the night. And even during the penumbra eclipse, my own experience was, I didn't expect it to be as dark, but it did become quite dark, very dark and very cold during that. So that is the amazement, and we feel the emotion, and we want everybody to feel that emotion also. Thank you very much, Rosa.
Well, we have here several examples of possible observations. Of course, the best is the special lenses, but if it is possible also to project by binoculars, if you don't have a telescope, that a telescope is not normal in one school, then this is one possibility. It is only necessary to use one part of the binoculars, not only both. And we have here the projection of the moon. But another possibility is by a camera obscura. And in this case, the idea is to use a tube or something like that, and to put in one part one piece of aluminum paper, and in the other part, for instance, a plastic bag is good because it is enough transparent in order to observe at first the sun, after begin the eclipses, and after, for instance, here at the last part of the eclipses. That means one possibility. Also, this material is possible to use in order to calculate, for instance, the diameter of the sun by a proportion if we know the distance from the sun to the earth. That is one astronomical unit, 150 million kilometers. Then it is possible to calculate the diameter of the sun, and the results are not very bad. There are other possibilities.
Rosa, can I just mention one thing, that the camera obscura in
Yes,
English
of course.
call it a pinhole camera, something.
Of course, I pass the next one. Yes.
Yeah, yes. Thank you.
If you want, you explain and I try to find the video, okay?
Yeah, okay. You see, this is such a simple access equipment. You need a tube. Yeah, sometimes we have tubes from, where we get posters or something, or you can even have a poster which you can roll up and you can make so on one side you block it up with some dark paper, some thick paper, and in which you make a hole, and on the other side you have a thinner paper, if translucent if possible, translucent paper. And when you point such a tube towards the sun, you can, if you align it well and you can hold it steady, you can see the image of the sun on the screen, on the translucent screen on the other end, which is made through the pinhole, which you have made in the camera there, in the tube on one side. Okay, we can see the video now.
I'm sorry, but I have difficulties with the video.
Okay. Do you want me to show the video? I have the video.
Yeah, I find it. Sorry.
Okay. Yeah.
I am not especially good in these things. So.
Yeah. Oh, this is very nice. You can see how simply Rosa has made this camera, this pinhole camera. You can see it is such an easy way to do this. Roll up a poster, cover one side with some thin paper, rubber band. Then on the other side, you want it completely opaque. So you use an aluminum foil. Cover it up completely. The rubber band again. Then now you want to make a hole. So you can see she's showing you a paper clip. Sometimes we say pinhole camera. Sometimes people think it has to be a very, very small hole. If it's too small a hole, you won't see an image because enough light has to pass through. So it has to be a relatively thick hole. And it doesn't have to be round, by the way. It can be even a rough shape. It will still make an image. Now you can see the image now on the other side. You'll see that she's pointing it towards the sun. The sun is very high, so it's a bit difficult, but if it's low, it is easy.
Yes, it was during the summer. It was very hot.
Very exciting experiment.
You can see. I hope, yeah. You can see the image.
I want to repeat the first part because I didn't show you the first part. I think it is only a poster, no more.
Yeah. So just a poster. It's a poster. You roll it up and rubber bands and a bit of paper and aluminum foil, and you have a very good demonstration, very good equipment to make an image of the sun.
Very easy, simple, not expensive. Because after that, you can use the poster in a normal way. This is not a problem.
Very well.
Okay, well, I finished.
You can leave that now, yes.
The rest doesn't matter, okay? Okay.
So now the next slide, you can go on.
Yeah. One moment that I need to put here the next slide. Oops. How? You can see now? Yes?
Yeah. Yes.
Excellent. And this is a collection of sympathetic pictures, I think. That's not especially interesting, but it is only to make a hole in order to observe the eclipses.
Eclipse.
If you want to continue,
It's the crescent of the eclipse, you know.
yeah. Yes, and then you can do with your hand. It is very simple. Okay, there are a collection of children that doing, or you use the hole from a different kitchen devices that you can obtain. Not only one, you can obtain several of them here or here. It doesn't.
Rosa, it's a good game for children to play.
Yeah.
And very artistic, very artistic.
Yes.
And they can try different objects and they play. I think it is good. And this is very funny also with the hole that pass in between the leaf of one tree. Yeah. And there are several pictures here. This is in the soil. This is on a house. And here is on the t-shirt of one of the students. And I think this is very nice because this was an annular eclipse that it was in Madrid. I don't know, maybe.
Oh, this is wonderful.
I think he is not so happy about that.
And also the face of the student is very beautiful. Yeah. Yes, it's a very, very amazing. Okay. And well, I would like to finish with this sentence that normally I use always in our presentations in NASE. People know that Rosa enjoy a lot because I think it is very interesting for us, and it's exactly the mentality that the methodology that we use in NASE. I hear and I forget, I see and I learn, I do and I understand. Then we try in our courses that the people do and then understand, because when you are using all your body in some way, you learn using, you understand using all your body, okay? Then this is the sentence. I don't know if this confuses the author or not, but well, it doesn't matter. The sentence is fantastic. Then thank you very much for all of your help, Mahdi and Jiwaji. And I don't know, but we finish a little bit before. Maybe we have the opportunity to answer any questions if we have them. I don't know.
Rosa, excuse me.
Yeah.
Can I, this sentence and this word, it's very beautiful. Can you show the slide again? I want to translate it for my Iranian.
Yeah, of course. Okay. Yes, please.
دوستان عزیزم، یک جمله بسیار زیبا از کانفوسیوس هست که میگه من میشنوم و فراموش میکنم، من میبینم و یاد میگیرم، انجام میدم و متوجه میشم. Thank you so much.
Thank you, Mahdi.
Can I do the same thing in Kiswahili, please?
Yes, Jiwaji.
Yeah, okay. In Kiswahili.
Do you want to translate also?
Yeah, yes. Can I say it in Kiswahili?
Yes.
He would say, ukisikia kuhusu kitu utakifahamu kidogo, lakini utakisahau. Lakini ukikiona utajifunza zaidi. Lakini ukikifanya kwa vitendo ndio utakielewa vizuri kabisa. Asante.
Thank you. And I can say in Spanish if you want, but this afternoon we have a Spanish session. Then I think it's not necessary. Then I will say in my language. I am Catalan and we speak a different language. Only 7 million people, but ho vaig sentir i ho vaig oblidar, ho vaig veure i ho vaig aprendre, ho vaig fer i ho vaig entendre. Thank you very much.
Thank you. Thank you.
I don't know if we have any questions, maybe.
Yes, Rosa, I think there are some in the chat.
Okay. I didn't see the chat, sorry. I was
And comments also.
busy
Can you see the
making
chat,
mistakes.
Rosa?
Yes. Do you want to give me some summary or
Well,
something?
there is a question from YouTube transmission. Someone asked Aurelian Buiasso, if we move to the north, we end up meeting in a spherical environment. It means the Earth. I don't understand very well the question.
I
But
don't understand the question, sorry. Could you repeat, please? Because I don't understand.
well, there are a lot of congratulations by the people and greetings from many, many countries. And some people ask for the materials, Rosa.
Yeah.
Yes, if they are available, if they can have the possibility to download the material, you can talk a little about the website if you want.
Yes, our website is open to everybody. Is NASE program doc, no, org, sorry. And then all the information is there. You can obtain these materials, information about these materials, and all.
I put the link on the chat.
Yeah, we have a lot of materials, and then I think it is easy to produce all the activities and all the models because we use simple materials, a glass, and a stick, and a string, very simple things. Then the idea is that the people can use these simple materials in order to understand much better and to think about what they are doing and what means that at the level of the astronomy. I want to show you one simple model that I just produced this morning, because when I discovered that to use that in the computer with the online service was difficult. Then I use a similar model. I don't know if you can see. This is the small Earth. This is the small moon, okay? And I use my mobile as the sun. And then it is possible to reproduce the same videos that we show you with the sun. The quality is not the same. This model is not so good, but it is easy to show here in order that I can show all the materials inside the video, no? Then inside the camera. Then in this case, for instance, my position is there. Then if I am observing from the Earth, I am here. Yes. If I am exactly in this position here, my observation is that the moon covers the sun. This is a solar eclipses because this appears the sun. And when I am in this position from the Earth, I look at that my shadow covers the moon, that from the Earth, this is a lunar eclipses. I think it is a very simple model in order to use in this situation.
It's a smaller model, so it is easier to handle. You know, it's a smaller model, which is easy to handle.
But to use with the students is better the other one, because in this case
of course,
the light too much close to here, and practically the solar eclipses are for all the Earth. You understand? The model is not so good.
The light is not parallel, of course. Yeah.
It is only that to show in this position and in this, okay? And I think it is easy in order to manage in this situation that it is not normal, okay? But well, there are a lot of activities, a lot of materials in NASE. And if you want, please contact me or contact Beatriz. Beatriz is the co-chair of NASE. We are working together. Beatriz is working more in Asia, in America, sorry, and Rosa in Asia and Africa and Europe, of course. Then I think it is easy to contact with us. And if you are interested to be members of NASE and to create a local group in your country, in your city, we can organize the activities and you can do it with us. No problem. We are open to everybody and we are interested to work with all the people in all the countries, with all the language that you want, no problem. Thank you very much.
Thank you,
Corina,
Rosa.
I will continue with the questions. Corina, who is one of the NASE members, mentioned that NASE is equivalent at a huge work to teach the teacher how to teach astronomy and astrophysics as simple as possible. So thank you, Corina. You are a great collaborator.
Yes, we have a wonderful team of people. I showed you before that we are more or less 800 people in the world.
Well, we have some comments also in question and answers window, but are just congratulations well, the copy of the presentations, yes, they are all available at the NASE website. I cannot see the NASE website. Sorry, Jiwaji. If you want to write,
I put it in.
What
Wait.
about we put in the chat? Okay.
Yeah. Let me put it in the chat. I'll put it in the chat just now. Just hold on.
Okay. I repeat.
Yes. Me too.
It's okay.
Wow, we have a lot of.
Yeah. Well, there is all the material. All the material that we use are there, even the videos. So you can download the material. Is free. Is for free. There is a book. Would you like Rosa talk 1 minute about the book, the reference book for NASE?
In the book, we have all the materials that we use in the PowerPoints with the same pictures, all exactly the same information. But in the book, you can find all the comments that I introduced here. Okay. Then I think it is an excellent material, a complementary material to the PowerPoints. And the book is translated now in eight different languages. And at the beginning of 2021 will be in 12, okay? Because we are working strongly about this. Then I think it is a wonderful information, and people normally use the proceedings, the book, use the PowerPoints, and also I put my email address in the chat. If you want to contact with me, I am open to talk with all the people interested. I am very happy if you involve and you participate in NASE and help us that the people fall in love with astronomy. This is our objective. Do you agree, Beatriz?
Yes, of course. Well, thank you very much, everyone.